So with question 4, okay, the left-hand side here is equal to cosec squared x minus sec squared x. Now, when I looked at this previously, I think one of the best ways of doing this is to consider, obviously if we use the result sine squared x plus cos squared x equals to 1, and then if we divide by sine squared x, okay, as we normally do to get the other results, if you remember, so divide by sine squared x. Oh, don't need an equals there. So this becomes 1, that becomes cot squared x, and then this becomes cosec squared x, yeah? So 1 there, that's cot squared x because it's cos over sine, and then because it's 1 over sine is cosec squared x. Now what we could do then in this left hand side is replace the cosec squared x with 1 plus cot squared x. Okay, so I'm literally replacing it with the result here, minus then sec squared x. Now we can look at our result, which is cot squared x minus tan squared x. Now I've got a cot squared x in there. The issue is, of course, now I've got sec squared, and I need to have tan squared, of course. And I've got this 1 here. So what I can do again now is using the result sine squared x plus cos squared x equals 1, and this time of course divide by cos squared x. Okay, divide every term by cos squared x. So this becomes tan squared x plus, that becomes 1, and that becomes sec squared x. So those are the other results that we need to obviously use quite a lot, and they'll come up in the exam always, but it's a good way to recall them by just using sine squared x plus cos squared x equals 1. So now what I can do is then going back to this result here now is replace 1 then plus cot squared x, replace the sec squared x with tan squared x plus 1. But remember, it says here minus it, so we need to take away all of this here. So I'm going to put it in a bracket. And we get then, well, the 1 then will cancel with that 1, won't it? Because we've got to take it away, remember. Okay, so I mean, if you want to be really explicit, you can sort of state that there. So the minus applies to this, and the minus then applies to this. So we end up then getting cot squared x minus tan squared x, which is equal to the right-hand side, which is what we need. So the result is proven.